Hello everyone, welcome to this session. In our previous session, we solved some examples on Fourier integrals, Fourier cosine integrals and Fourier sine integrals. In this session, we are going to solve some more examples on Fourier integrals, Fourier cosine and sine integrals. Here I have listed 4 examples. In our previous session, we solved 4. Now we are going to solve 4 more examples. So first one is using Fourier integral representation, show that integral 0 to infinity sine omega cos omega x upon omega d omega equal to pi by 2. So here given function is not given, it is asked to find this integral. So, whenever function is not provided, we consider RHS of this integral as a function. So, here let fx equal to pi by 2 into 1. Okay, that is pi by 2. Now, here integrand contains both sine and cos terms. Both sine and cosine terms. So here sine omega cos omega x upon omega is even function. Since if you put omega equal to minus omega, then what do you get? Sine minus omega into cos of minus omega x upon minus omega, which is equal to sine omega minus omega is minus sine omega into cos omega x upon minus omega. So here this is nothing but this given expression. This one and this one are same. So this is even function. When function is even, we use cosine integral formula to evaluate the integral. So here using cosine integral formula, we can evaluate the integral. Here this function is even function because whenever we replace omega by minus omega, here we got same function, sine omega cos omega x upon omega, same terms. That's why this integrand is even. When integrand is even function, then we use cosine integral formula. So here cosine integral formula is, what is cosine integral formula? Cosine integral formula is fx equal to integral 0 to infinity a lambda cos lambda x d lambda. Now a lambda equal to 2 by pi integral 0 to infinity f of t cos lambda t dt. But here this function, here it is given 0 is less than or equal to x, less than or equal to 1. So this function here x is in between 0 and 1. So 0 less than or equal to x, which is less than 1. So a lambda equal to 2 by pi integral 0 to 1. Here f of t, value of f of t is pi by 2 into cos lambda t dt, because if f of x equal to pi by 2, then f of t is also equal to pi by 2, and 0 less than or equal to t less than 1. That's why here we have taken limits from 0 to 1. Here we have taken pi by 2 in the place of f of t into cos lambda t dt, which is equal to 2 by pi into pi by 2 integral 0 to 1 cos lambda t dt. Then here these terms will get cancelled. We get a lambda equal to integral 0 to 1 cos lambda t dt, which is equal to, if you integrate this, here sin lambda t upon lambda under the limits 0 to 1, because integral cos x dx equal to plus sin x. Then if you apply upper limit, you get sin lambda upon lambda minus sin 0 upon lambda, which is equal to sin lambda by lambda. After finding a lambda, we replace value of a lambda in f of x. F of x equal to integral 0 to infinity a lambda cos lambda x d lambda. So which is equal to integral 0 to infinity sin lambda upon lambda into cos lambda x d lambda. But what is f of x? F of x is nothing but pi by 2. We have taken f of x as pi by 2. So here in the place of f of x, we can write pi by 2. Therefore, integral 0 to infinity sin lambda upon lambda into cos lambda x d lambda equal to pi by 2. If you replace lambda by omega, then we get, here if you put lambda equal to omega, then we get integral 0 to infinity sin omega upon omega into cos omega x d omega equal to pi by 2. Okay, here integral 0 to infinity sin omega cos omega x upon omega d omega equal to pi by 2, which is required solution. Now let us see sixth question. Sixth question is express f of x equal to 1 for 0 less than or equal to x less than or equal to pi, and 0 for x is greater than pi, as Fourier sine integral, hence evaluate integral 0 to infinity 1 minus cos pi lambda upon lambda into sin lambda x d lambda. Now here it is directly asked to find sine integral, because express fx as Fourier sine integral, hence evaluate this integral. So first we have to find sine integral using given function. So here given that f of x is given, f of x equal to 1 for 0 less than or equal to x less than or equal to pi, 0 for x is greater than pi. So first write given function, then write formula of sine integral, because here we have to find sine integral first. So here sine integral is fx equal to integral 0 to infinity b lambda sine lambda x d lambda, where b lambda equal to 2 by pi integral 0 to infinity f of t sine lambda t dt. Okay, so here f of t is f. Here what is f of x? F of x equal to 1 for 0 less than or equal to x less than or equal to pi, 0 for x is greater than pi. Right, so f of t is also equal to 1 for 0 less than or equal to t less than or equal to pi, and 0 for x is greater than pi. So here we can divide or we can split this integral as integral 0 to pi f of t sine lambda t dt plus integral pi to infinity f of t sine lambda t dt. Okay, so here in this interval 0 to pi, value of f of t is 1. But here in the interval pi to infinity, value of x is greater than pi means pi to infinity. Here value of f of t is 0. So here we can write this integral as 2 by pi. So second integral becomes 0. So first integral can be written as integral 0 to pi f of t is 1. So here 1 into sine lambda t dt, which is equal to 2 by pi integral 0 to pi sine lambda t dt. Now this is equal to 2 by pi integral sine ax dx equal to minus cos ax upon a. So here we get minus cos lambda t upon lambda under the limits 0 to pi. So first put t equal to pi. So here minus of cos lambda pi upon lambda. Here when you apply lower limit, this sign becomes positive. Sign changes. So here plus cos 0 upon lambda. Here value of cos 0 is 1. So we get 2 by pi. Here minus cos lambda pi by lambda plus 1 by lambda. If you take LCM, you get 2 by pi. Here 1 minus cos lambda pi upon lambda. This is b lambda. Now fx equal to, what is fx? Integral 0 to infinity b lambda sine lambda x d lambda. So here in this formula, first let us put value of b lambda. So if you put value of b lambda here, you get integral 0 to infinity 2 by pi into 1 minus cos lambda pi upon lambda into sine lambda x d lambda. Sine lambda x d lambda, that is 2 by pi integral 0 to infinity 1 minus cos lambda pi upon lambda into sine lambda x d lambda. But what is f of x? In the interval 0 to pi, value of f of x is, here it is 0 to infinity, right? So here, if you consider 0 to 1, 1 to infinity, that means here this is left side to this one, and this one is right side. Here right side, left side. So here you can consider this as f of x equal to f of x plus f of x minus upon average. That means here on left hand side it is 1 in the interval 0 to 1, plus in the interval 1 to infinity it is 0. So upon 2, which is equal to 1 by 2. Okay, so here in the place of f of x you can write 1 by 2. F of x equal to 1 by 2. Now transpose this 2 by pi to left hand side, then you get 1 by 2. Let us write on next page. So here that is 1 by 2 into pi by 2 equal to integral 0 to infinity 1 minus cos lambda pi 1 minus cos lambda pi upon lambda into sin lambda x d lambda. That implies integral 0 to infinity 1 minus cos lambda pi upon lambda into sin lambda x d lambda equal to pi by 4. So here let us check the question. So here we have to evaluate this integral 0 to infinity 1 minus cos pi lambda upon lambda sin lambda x d lambda, that is equal to pi by 4. Now let us see next question. Next question is find Fourier cosine. Seventh question is find Fourier cosine and sine integral representations of the function fx equal to cos x in the interval 0 less than x less than pi by 2 and 0 when x is greater than pi by 2. Here this is direct question because it is asked to find cosine and sine integrals by providing the function fx. So directly by using formula of cosine and sine integrals we can find this sine and cosine integrals using formula. So here given function is fx equal to cos x in the interval 0 less than x less than pi by 2, 0 when x is greater than pi. So first find cosine integral. Okay, we have to find both the integrals, cosine and sine integrals. So first let us find cosine integral. Cosine integral formula is fx equal to integral 0 to infinity a lambda cos lambda x d lambda. A lambda equal to 2 by pi integral 0 to infinity f of t cos lambda t dt. So using this formula, first let us find a lambda. So here a lambda equal to 2 by pi. Here function is given in 0 to pi by 2 and pi by 2 to infinity. Here this limit means pi by 2 less than x less than infinity. So we can split this integral into two integrals. First one is from 0 to pi by 2. Next one is from pi by 2 to infinity. So you can write this a lambda as integral 0 to pi by 2 f of t cos lambda t dt plus integral pi by 2 to infinity f of t cos lambda t dt. But in this interval 0 to pi by 2, so here a lambda equal to 2 by pi integral 0 to pi by 2 f of t cos lambda t dt plus integral 0 to plus integral pi by 2 to infinity f of t cos lambda t dt. Here in the interval 0 to fx, what is fx? Fx equal to cos x in the interval 0 to pi by 2 and 0 in the interval pi by 2 to infinity. That means f of t equal to cos t in the interval 0 to pi by 2 and 0 in the interval pi by 2 to infinity. So here in the first interval, the first integral 0 to pi by 2 f of t is cos t, and in the second integral f of t is 0. So here to evaluate this, first we have to apply cos A cos B formula. So cos A cos B equal to 1 by 2 into cos A plus B plus cos A minus B. So apply this formula first. So here we get cos of 1 by 2 into cos of t plus lambda t plus cos t minus lambda t dt. Now if you take this 1 by 2 outside, you get 2 by pi into 1 by 2 integral 0 to pi by 2. Here cos of 1 plus lambda into t plus cos 1 minus lambda into t dt. Now you get 1 by pi. Here these numbers will get cancelled. Integral 0 to pi by 2 cos of 1 plus lambda into t plus cos. So you can split this integral because there are two terms here. So here 1 plus cos lambda t dt plus integral 0 to pi by 2 or you can evaluate directly without splitting this. So this is equal to 1 by pi integral 0 to pi by 2 cos of 1 plus lambda into t plus cos 1 minus lambda into t dt. Now integral cos ax dx equal to sin ax upon a. So if you use this formula here, you get 1 by pi here sin 1 plus lambda into t upon 1 plus lambda plus sin 1 minus lambda into t upon 1 minus lambda under the limits 0 to pi by 2. Now apply these limits. First put t equal to pi by 2, then put t equal to 0. That is equal to 1 by pi here sin of 1 plus lambda into pi by 2 upon 1 plus lambda plus sine 1 minus lambda into pi by 2 upon 1 minus lambda minus sine 0 upon 1 plus lambda minus sine 0 upon 1 minus lambda. Now this can be written as 1 by pi sine pi by 2 plus lambda pi by 2 or pi by 2 lambda upon 1 plus lambda plus sine pi by 2 minus lambda pi by 2 upon 1 minus lambda. Here this becomes 0 and this becomes 0 because sine 0 equal to 0 and sine cos theta, sine pi by 2 plus theta equal to cos theta because pi by 2 minus theta is in first quadrant and pi by 2 plus theta is in second quadrant. In both the quadrant these angles equal to plus cos theta. So here sine pi by 2 plus lambda pi by 2 gives cos lambda pi by 2. Here sine pi by 2 minus lambda pi by 2 gives cos lambda pi by 2. So we get 1 by pi cos lambda pi by 2 by 1 plus lambda plus cos lambda pi by 2 by 1 minus lambda. Then if you take cos lambda pi by 2 common, we get cos lambda pi by 2 upon pi into 1 by 1 plus lambda plus 1 by 1 minus lambda. Here if you take LCM, 1 minus lambda plus 1 plus lambda upon 1 plus lambda into 1 minus lambda, that is 1 minus lambda square. Then we get 2 cos lambda pi by 2 by pi into 1 minus lambda square. This is a lambda. Now fx equal to integral 0 to infinity a lambda cos lambda x d lambda, which is equal to integral 0 to infinity 2 cos lambda pi by 2 upon pi into 1 minus lambda square into cos lambda x d lambda. This is required integral. Now we have to find sine integral. This is which is cosine integral. Now here sine integral is fx equal to integral 0 to infinity b lambda sine lambda x d lambda. B lambda equal to 2 by pi integral 0 to infinity f of t sine lambda t dt. So which is equal to 2 by pi integral 0 to infinity, but here integral 0 to infinity can be written as integral 0 to pi by 2 f of t sine lambda t dt plus integral pi by 2 to infinity f of t sine lambda t dt. We know in the interval 0 to pi by 2 f of t is cos t. In the interval pi by 2 to infinity f of t is 0. So we get 2 by pi integral 0 to pi by 2 cos t into sine lambda t dt. So to evaluate this integral, first we have to simplify that integrand. So here 2 by pi integral 0 to pi by 2 cos t into sine lambda t dt. Now cos a sin b equal to 1 by 2 into sine a plus b minus sine a minus b. So apply this formula to simplify cos t into sine lambda t. So b lambda equal to 2 by pi integral 0 to pi by 2 1 by 2 into sine of t plus lambda t minus sine t minus lambda t dt. t minus lambda t dt. That is 2 by pi integral 0 to pi by 2. Here you can take this 1 by 2 outside. So here into 1 by 2. Here sine of 1 plus lambda into t minus sine 1 minus lambda into t dt, which is equal to 1 by pi integral 0 to pi by 2 sine of 1 plus lambda into t minus sine 1 minus lambda into t dt. Now integral sine ax dx equal to minus cos ax upon a. So here we get 1 by pi into minus cos 1 plus lambda into t upon 1 plus lambda minus of minus cos 1 minus lambda into t by 1 minus lambda under the limits 0 to pi by 2, which is equal to 1 by pi minus cos 1 plus lambda into t by 1 plus lambda plus cos 1 minus lambda into t by 1 minus lambda under the limits 0 to pi by 2. Now let us replace limits, that is 1 by pi, let us substitute those limits, minus cos 1 plus lambda into pi by 2 upon 1 plus lambda plus cos 1 minus lambda into pi by 2 by 1 minus lambda. Here plus, whenever you are applying lower limit, these signs they will change. So here minus becomes plus. Here cos 0 upon 1 plus lambda minus cos 0 upon 1 minus lambda. Here cos 0 is 1, so we get 1 by pi minus cos pi by 2 plus lambda pi by 2 pi by 2 plus lambda pi by 2 upon 1 plus lambda plus cos pi by 2 minus lambda pi by 2 upon 1 minus lambda plus 1 by 1 plus lambda minus 1 by 1 minus lambda, which is equal to 1 by pi. Here cos 90 plus theta is minus sin theta. So minus sin lambda pi by 2 upon 1 plus lambda. Here plus cos pi by 2 minus theta is plus sin lambda pi by 2 upon 1 minus lambda plus 1 by 1 plus lambda minus 1 by 1 minus lambda. So here you get 1 by pi, here sin lambda pi by 2 upon 1 plus lambda plus sin lambda pi by 2 upon 1 minus lambda plus, here if you take LCM, 1 minus lambda minus 1 minus lambda upon 1 minus lambda square. So here minus 1 plus 1 will get cancelled. We get 1 by pi. Here if you take sin lambda pi by 2 common, again you get 1 by 1 plus lambda plus 1 by 1 minus lambda plus minus 2 lambda upon 1 minus lambda square. That is 1 by pi into sin lambda pi by 2. Then here LCM is 1 minus lambda plus 1 plus lambda upon 1 minus lambda square. Here plus minus 2 lambda upon 1 minus lambda square. That is here 1 by pi 2 sin lambda pi by 2 upon 1 minus lambda square minus 2 lambda upon 1 minus lambda square. So if you take 2 outside, 2 by pi, here sin lambda pi by 2 minus lambda upon 1 minus lambda square. This is b lambda. Now after getting b lambda, we have to replace b lambda in the f of x by this particular value. Then fx equal to integral 0 to infinity b lambda sin lambda x d lambda, which is equal to integral 0 to infinity 2 by pi sin lambda pi by 2 minus lambda upon 1 minus lambda square into sin lambda x d lambda. This can be written as 2 by pi integral 0 to infinity lambda minus sin lambda pi by 2 upon lambda square minus 1 into sin lambda x d lambda. Okay, this is required solution.